Today's webinar will focus on how you can get the most out of calibration in SAP with Vesta's QMC solution. Please know that you can ask questions during this webinar through our GoToWebinar questions panel, and they will be answered at the end of our session. Our host for today's webinar is Peter Mopert, the Director of Vesta's Software Products. He is responsible for software product development and building applications for SAP QM. He has over 16 years of software development experience specializing in application integration. And with that, I will turn the session over to Peter.
Thanks, Asha, and thanks everyone for joining. So we'll be going over just briefly the standard calibration process in SAP. So if you don't have QMC, the way that you would do that, we'll go over that. And then we'll do an overview of QMC and then a demo of both the standard process and also what you can do with Vesta QMC. And time permitting, we will do a few advanced features as well. And then at the end, we will have a Q&A session. And please, throughout the session, if you have any questions, just post them in the chat room, please. So as far as calibration in SAP goes, it is an integration between the plant maintenance and quality management modules. And to the effect that you have the inspection lots in the QM module that are used extensively for material testing and analysis of both raw materials and the final product. And these inspection lots are then used in PM to enter your calibration data of test equipment. Inspection characteristics are used to define individual parameters that need to be tested. So in our examples today, we'll be showing the calibration of a temperature gauge. So for, let's say, the 50 Fahrenheit calibration and the 100, those are all inspection characteristics that have to be defined. Inspection characteristics are then grouped into inspection lots. These are assigned to work orders and task lists. Results are then recorded, and then those results are compared against specifications. During your results recording, you enter your raw data, so the 50 Fahrenheit degree reading is a result that you have to enter manually. And then at the end, you take a usage decision based on what your calibration data was. And SAP then takes that usage decision and it can do follow-up actions. In our examples, we will technically complete a work order, but you can do multiple things from notification creation or equipment replacement or a repair to time confirmations to equipment status updates and workflow for emails. As far as the benefits go of using calibration type work orders in SAP, well, it allows you to have all of your work order types, your corrective, your preventive, and calibration order types in one system. So you don't have to integrate with any third-party systems. Everything is in SAP. Calibration usually requires too many measurement readings to make use of the measuring point functionality in SAP. So that's where this functionality comes in useful. You make use of SAP's planning engine, so you can schedule your resources and your materials right within SAP. You still have access to standard SAP transactions for work control, and it is SAP that does all your cost recording and it keeps the calibration history for analysis and reports. Using calibration test instruments or use of calibration test instruments is tracked using serialization or equipment numbers, which provides a linkage from your test equipment to your field instrument. And again, in what all this summarizes is that you have all of your data still in SAP. SAP manages all of it, and you have it all available for statistical analysis and of your entered data. There's no requirement for any third-party applications externally or external integration. Where QMC comes in, it is an SAP certified add-on, and it supplements the QM and PM functionality in SAP in three areas. One in the configuration of your calibration information, we make it a little bit easier, as you'll see. Secondly, during the capturing of your calibration information in the inspection lot, we have some additional information. We can record lab standards that were used at this point. And then thirdly, on the reporting side, we have a few reports available, and we also have the ability to print a calibration certificate for you based on your inspection lot results. All of this functionality in QMC is driven by a new master data object that we call data sheets. And data sheets act as templates where you can assign one or more technical objects, so an equipment, and even on the functional location level, you assign similar ones to a data sheet. So if you have 50 temperature gauges that need to be calibrated to the same specifications, you can assign all 50 to the same data sheet. And the data sheet then has what we call functions, which are similar to operations on a work order. And these functions themselves then specify the tolerances on each of the readings that are required. So the different limits that are set, the calculation types that are required. These will become a little bit more clearer during the demo. But the data sheet is the vehicle that drives this functionality from a configuration standpoint. Some of the benefits that this brings to the table is, I mentioned the recording of lab standards already. The way that you would do this in the normal SAP process is to define the standards already on the task list. But if you are out in the field and you're doing your calibration and you happen to not have that exact standard with you but a different one, there's no way for you to record that in the standard SAP process. With us, we now have a button on the results recording screen where you can enter these standards that were used. Secondly, we have different reading types, so in particular as found and as left. As you may know, when you set up master inspection characteristics for your typical process, you already have to define your as left values in addition to the as found, even if during your inspection, your results recording, they are the same. So if you didn't have any issues with the as found, you still have to go ahead and enter the as left. With QMC, that is no longer the case. On the equipment itself, we have some characteristics that we update. In particular, we have the calibration due date. So when is this piece of equipment or the functional location next due for a calibration, and the last time this equipment was calibrated. And this can come in very handy if, in, for example, the pharma industry, you have a production run. You want to know ahead of time if all the equipment that you will be using has been calibrated and is within the due date. We have functionality that we like to call spot checking, where you base your actual reading on the standard reading. We can do linear calculations, so if your input and output have some ratio to them, we can calculate those outputs for you. All of these data sheets and the equipment and functional locations assigned to them, we can create those en masse with Excel templates. I already mentioned the calibration certificate. This is typically something we customize for our customers. It's a smart form. And then we have it set up so that you have to enter a digital signature, so your SAP username and password at certain areas. So after I've recorded my as left, my as found, and then after the usage decision has been taken. So let's just go over at a high level, the standard process in SAP to do calibration. So you start out with an equipment master record. Then you create your master inspection characteristics. So again, on our temperature example, or temperature gauge, you'll have, let's say, a 0 Fahrenheit, 50 Fahrenheit, 100 Fahrenheit. So each of those will be a master inspection characteristic that you need to create. Then you assemble those into a task list for that particular instrument. You create a maintenance plan referencing the task list in step 3. You schedule your maintenance plan and call the work order. And then you enter your results from calibration into the inspection lot, and you take a usage decision for that inspection lot. And the steps 2 through 4 that I've highlighted here is where a lot of work has to take place. So creating the master inspection characteristics for each of your different equipment types is quite cumbersome, and then assembling those into different task lists is equally cumbersome because each of those task lists is specific to an equipment. The process with QMC starts out the same, so you obviously need an equipment. Then on this equipment, you assign a QMC characteristic class that has some specific characteristics that we need. You create a data sheet and assign all related equipment, or if you already have a data sheet with related equipment, you just assign it to that. You create a maintenance plan for the instrument, but you reference only a generic QMC task list. So for all of QMC, there's one task list that is used that is very generic. So from here on out, it's the same again. You schedule your maintenance plan and you could call the work order. At this point, QMC steps in, looks at if the equipment is assigned the characteristic. If so, it goes and looks for the data sheet, and then ad hoc, it creates the master inspection characteristics. Then you enter your results as usual, enter your usage decision, and also we have the ability to record the standards that were used during this process. So what this looks like, this is an equipment master record. We've added a tab here with the characteristic, the class that we have assigned, and you have to set this use datasheet to yes if you want this piece of equipment to be picked up. And then these two fields here, the calibration due date and the last calibration date, these are the ones that we calculate and populate on the equipment. This is not available in your typical SAP installation. This just briefly is what a datasheet looks like. At the bottom here, these are the sequence of readings that the end user will have to take when they do their inspection. And here's an equipment that is assigned. Again, you can assign multiple of the same equipment. And then this is what it looks like when you do your documenting of the standards that we use for a calibration. We have a stop-go kind of sign on the left. So if this standard was within its due date at the time of calibration, you get a green light. If it isn't, then you get a red light warning you that your standard itself needs to be calibrated. The reports I touched on earlier, so we have the calibration certificate that is printed, which is our customizable smart form. We have a traceability report so you can determine where your standards were used. So if, say, down the line you realize that one of your standards is no longer up to specification, you can go back and see which calibrations were performed using that standard and then act accordingly. You can see which equipment is used on which data sheet. Have a look at, you can upload the data sheets from the Excel templates like I described. And then lastly, we have an audit log where you can see which changes had taken place on your data sheets by who and when. So the few additional features, and I'll try to touch on these time permitting in the demo. We can do reading point specific sequences. So each of the readings I showed in the previous screen for the weight, there was a 20, a 60, and 100. For each of those, you can specify different calculation types. So one might be based on a percentage of the input reading, while the other is a plus or minus of the input kind of thing. Linear calculations I explained already, where you have a ratio between your input and output. And then lastly, we have support for guardbanding, which essentially is just an adjustment of your limits to lower than what the specification limits actually are. So you narrow the band of acceptable values that you can accept. And with that, we will go to a demo. Please remember to post any questions if you have any. So you should see on the left-hand side is the SAP screen. And what I've done on the right-hand side is a checklist of the steps I'll be going through, both for myself to keep track and for you as well to follow, since there are quite a few screens that I have to go to. This allows you as the viewer to follow along. So we're going to do the regular or standard SAP process first. I've created some of this data already in the interest of time, but you should be able to get a good feel for what the process is involved. So let's start with just the standard SAP process that you would take if you wanted to do some calibration. So I already created an equipment, and we're just going to briefly show this equipment. So this is just a temperature gauge, and there's really nothing special about it. I haven't added any information. Of course, you can add your manufacturer information, etc. But this is just very standard for our demo. We will go create one master inspection characteristic. So we've done this. Let's create a master inspection characteristic, and we shall call it temp 200. So we use plant 1000, and we call this temp 200. We'll make it quantitative. Let me release this immediately. We'll give it a description. 200 degrees. Okay, and I have to just enter some characteristics here. Control indicators. Should be good. And test equipment. And this gives us this field here. So let's say we want 2 decimal places. And it's going to be Fahrenheit. That's the unit. And let's say our target value is 200 degrees Fahrenheit. Lower specification limit, we can say 195 and 205. And let's say the plausibility limit of 180 and 220. So if you enter those, that's really out of spec. We'll continue, and I'll save this. Okay, so we've created one master inspection characteristic. Now, obviously, you would have to create multiple of these. I have already set one up earlier that we can now just add to. So we will change the task lists that I'm using for this. So we have a task list here for temperature gauge calibration. It is an equipment type task list assigned to this very equipment. And so here I've already, I've included already master inspection characteristics that I previously created. So the way that you want to do the calibration of a temperature gauge is typically you want to catch the value on when it's rising and then as well when it's falling. So we start with the 0 degrees as it's rising, then 100 degrees rising, then 100 degrees as it's falling. Oops, sorry. Then again 0 degrees falling. And then, of course, we have to specify it for the as left as well, so you have the same information repeated. I'm going to add the 200 degree temperature. I'm not going to insert it in between. Typically, you would set this up in sequence. It's going to be out of sequence just because of the way that I'm entering it late here. But I think it's still easy enough to follow along. Okay, and we'll do this 200 rising. Then we have to do a 200 degree falling. And then, of course, the as left rising and falling as well. So we'll do this twice. So this will be rising as left, yes, as left, and Unfortunately, like I said, these are a little bit out of sequence, but it should still be in order. Okay, so we'll save this. Okay, we've assigned our master inspection characteristic to the task list. Now let's go have a look at the maintenance plan that I previously set up for this. We'll just briefly look at what that looks like. So this is the equipment that we used, and then here we have the task list that we just had a look at and assigned our master inspection characteristics. Other than that, there's nothing special about it. Now we'll go schedule this, and I'll start the schedule today, and I'm just going to release this first one, even though we still have some time. And then I'll save it to call, and let's go back in. So you can see now this has been started, and we can look at the actual work order, which I will record as well, just so we have it for later. So we've scheduled. So here's our work order. It just has the one operation that we defined, and then these are the inspection characteristics that will need to be taken. And let me type that in. Right. This is our inspection lot, which we will use in the next step. And so you can see all of these characteristics have been generated from our task list. We'll go out, and then we will do results recording. This is transaction QE51N. I have the inspection lot already, so I'll just copy that. And this now allows us to enter our readings. So let me expand this a little bit. In the description, we have what needs to take place, and then in the specification, we have our ranges. So as you can see, again, this is a little confusing because I have the 200 degrees down here, but you have the as left in here also. Even if, say, all of my readings are within spec and I don't actually have to go do any adjustments to my equipment, I still have to enter all of the as left readings as well. So this, as you can see, so we'll do all my as found first. So let's say we had 199 and 200 this way. So now I have to go and do the as left as well. And in this case, it'll have to be the same values from before because nothing changed. So this is a bit cumbersome sometimes. And one more. So we will now save these. You can do a valuation here. These are the ones we actually set up for QMC, but in this case we'll say in tolerance not adjusted. And this is actually part of QMC already. It requires me to enter my username and password here to sign this digitally. And then the last thing that you do in this process is you take a usage decision, and we'll just say calibration performed. Save this again. Again, it requires me to sign it. And that completes the process. So if I were to refresh this, we will see that this is now gone. So we've done the calibration. So to show the follow-up action that I spoke about earlier, in our system we have it configured to do a technically complete of the work order. So I'll show that briefly. So on the work order system status here, we can see that it has now been technically completed. And we can look at the inspection lot as well here. These were all the results. And we can see here that it has a quality score of 100 because everything was in check. So that's the process you do in SAP today. Let's look at what that looks like in QMC. So we will have a look at our equipment again. So I created another equipment. It's very similar. The only difference is I have assigned this class, this Vesta Calibration, and it has these characteristics. And we also, if I go back, we added a tab where you can see these. So this just says, yes, I want to use a data sheet when doing calibration on this piece of equipment. So now instead of going to create master inspection characteristics and assigning that to a task list, I will go and make a change to a data sheet that I created previously. So this is the main screen of a data sheet. You can specify some information about the equipment type itself here, if this is of importance to you, which procedure, inspection method you want to specify, and these things can then be printed on the calibration certificate. I've left it blank for now. The first thing you want to do is assign the equipment itself. So we've assigned number 892, and again, here you could assign as many as you need for this particular type. You have different functions here, and in the examples today I only have one function, but you could have, let's say, if this wasn't a temperature gauge, but some other piece of equipment that required different types of calibration or reading, so maybe it required a reading of amps and voltages, you could have those in different functions here. So we'll have a look at this first function. In the top, you can specify some information about the instrument itself, so the instrument range, the calibration range that you want to deal with. We'll look at this linear calculation stuff a little bit later. Then we have three types of calculation types and limits that you need to set. So firstly, the plausibility limit. I like to call this the fat finger limit. So whether a value that you entered makes sense, really. So really, if you accidentally hit a key, that doesn't make sense. Then we have the adjustment limit. So if you've done your as found reading and you had to make some adjustments, you can limit or at least warn them if their adjustments seem a little bit out of spec. And then lastly is the process limit, and this is the one that is taken into account in the results recording itself. Now for each of these, we have different calculation types. So in this example, I'm just going to do plus or minus the entered unit, but we have different variations on this. So you can do a percentage of the range or a percentage of the standard. So this will, we'll see this in a further example. But this allows you to require the input of a standard, and then your actual reading is based on a percentage of that. So then just plus values, and then the other one we can do is just input itself. So this would require you to have an input value, and then you have to enter an output value, and the allowable output value will be calculated by QMC. Then this bottom section here, these, we call them sequences, and each of these is equivalent, if you will, to the master inspection characteristic that I set up earlier. So if I wanted to, let's add the 200 degrees like we have in our other example. So we'll do a rising of 200 degrees, this will be Fahrenheit. The output I expect to be 200, also Fahrenheit. And I want to actually insert this one between 20 and 30, so we'll just number this one 21. So now it is down here, as you can see. And let's add a falling reading, again for the 200 degrees. We wanted 200 in the input and output, and also I want this one in between. Okay, so this will now in the inspection lot give us a 0 degree rising, 100 degree rising, 200 degree rising, and then the equivalent falling in the opposite direction. So if I save this, so we've done this and this. Now we'll go show the maintenance plan that I have assigned to this. This will be quite familiar from our previous example. So here's our maintenance plan with this particular equipment assigned. Now the difference here is that I don't have a equipment task list. I have a very generic task list assigned. We can have a quick look at this. So these are the operations on the task list. We have multiple operations here. Each one of these will, when it is converted to an inspection lot, correspond to a function on the data sheet. So you just need to have some extra in here in case you have multiple functions on your data sheet. And we only have one characteristic on here, and it's just a template really. It's just a placeholder in comparison to what we had previously in the equipment task list for the standard SAP. So let me just go back. So there's nothing really special except that we have only this particular task list assigned. So now let's go and schedule this. This is the same process as before. I will release this one again. And at this point is where QMC steps in and creates the inspection lot based on the data sheet information. So let's go back in again so we can look at the work order itself. Let's make a note of this one again. And then this is now where the characteristics were generated from our data sheet. So I'll copy the inspection lot as well, so we use it. And you can see here now, you have the rising at 0 Fahrenheit, 100, 200, and then the same for falling. But what you don't see here, and there's no need for it, is the as left values. And you'll see when I actually do the results recording why that isn't required. So let's go to our results recording now. So we've done this, this, and this. I have the inspection lot number copied, so I'll use that. And so here's the first difference already. You're presented with this screen where you have to specify what type of reading it is. So since we are first starting out, we'll make this an as found. And now this is quite familiar. So these are the specifications that were generated. So now I go and do readings. And I'm going to make one fail so that we do the as left readings as well. So let's say we had a -3 on this one, and the others are okay. Let's say 200, 1, and 100, and let's fail this one too. Actually, that passes, but I just wanted to have a failure. One thing that we can do here is this button, this Record Lab Standard button, is a QMC addition. So if I press that, I have a standard that I set up previously for this. And so you can see it gives the green light, and it bases that on when this standard itself was calibrated last. So you can see the due date for this is out in the future, and it was very recently calibrated. So it is up to spec, so we are okay with this. So now I have to save this. Again, I do an evaluation. And the as found codes, yes, I want to say adjustment is required because we failed a value. Enter username, password for the signature. And then what we do is we do a further inspection here. And this time we do an as left. And now we can go and enter the as left values after we've fixed our equipment. And we'll make it pass this time, so everything's up to spec. Okay, now I could again record a lab standard here, but I will just save. Our evaluation now is intolerance adjusted, so that means we have to make some changes to it. Sign it once more. Now, this is something you can turn off if you don't like it. And then we will do the usage decision as before. And we'll say we calibrated this. Okay, and that completes the process from a QMC standpoint. I'm not going to show the T-code because it's the same as we saw before, but I will go and show you the calibration certificate. So I still have the, I will copy the inspection lot in here. And then I run this. And this will attempt to print, but I'm just going to print it, tell it to print, but I'll have to go look at the spool. Do say print. I'll let that run through. Okay, so typically your printer would be spitting something out right about now, but we'll go look at the spool. And so we should see one document here, and I'll open this up. And this is a very simplistic certificate. This is the standard one we deliver. I will, in just a minute, show another example of what we have done. But this is where you have, manufacturer information. The work order number is the certificate number here. You have information about who did it, what your as found and as left conditions were. I didn't enter any humidity or temperature information on the standards recording, but I could have done that. The standard that was used and the next due date on that standard, and then my as found and as left values. Again, this is not our best example, but let me show one example. So here's another example of one that we did for a customer. And you have a little bit more information. So here you have the different ranges and their specifications. My apologies. Again, when this happened, who did it, all the standards that were used, and then in this case, there were only as found values. And we even allowed them to do some remarks, etc. So this was something we can customize for the end user. So that's the standard process, and good, we still have some time. Let me show you some of the, let's call them advanced features. So the spot checking, which I mentioned earlier, this is where you require the input of a standard, and then your actual reading is based off of that. So let's look at the data sheet for this one. This is similar to the example that we just had, except we just have 0 rising, 50 rising, and 100 rising. I guess I skipped the 0 falling. But in this case, I changed this calculation type to plus or minus the standards reading. Before I had it set to plus or minus the entered unit, but in this case I have it on this standards reading. And how this will come into effect is in the results recording itself, which I've already created an inspection lot. So you can see here now, as opposed to our first example, we actually have double the amount of rows to enter. So this is because it now requires me to enter a value for my standard. So let's say my standard read 1 degree. Well, this is now going to look at the specification here after I hit enter. It will adjust accordingly. So we had said that the 0 rising is a plus or minus 2 of the standard. So if I change this to 1 now, well, that adapts the specification accordingly. So whereas before -2 would have been a valid value, it now no longer is, because it is now outside of the specification based on what your standard read. I'm not going to do the rest. it's clear of how that works. We will go and show the next type, and this is what we call reading point specific, and I'm also adding the output based on input reading. So let me just get out of here. We'll go look at the data sheet one more time. This is a different one again, although very similar. In this case, I selected this reading point specific that immediately grays out the process limit here. So I no longer have access to it here. But now instead, on each of these sequences, I can set a different reading, calculation type, and limit. So what I've done here, for example, on the 0, a percentage here wouldn't make sense. And I've made it plus minus of the input reading. And so you will see how that works, very similar to the where we specified a standards reading. And then on the others, I thought maybe a percentage made sense, so I said percentage of the input reading. So 5 and 6% on the 75 and 100 in this case. And then again, a plus or minus on the 0. So what this looks like in the inspection log that I have also generated is like this. So now again we have 2 rows for each reading essentially, and this is similar now. Instead of the standard that we had in the previous example, it's the input. But each of these specifications is calculated according to that sequence calculation type that I had set. So on the 0, I just had a plus or minus 2, and on the 75, I had I think it was a 5%. So again, here now, if I enter 1, it's going to change the specification on the 0 rising reading accordingly. So similar to what we saw before. Now again, if I enter -2, which was previously valid, it's going to fail. But alternatively, even a 2, or a 3, which would have failed earlier as well, is now an acceptable value. Except it goes past my adjustment limit, so that's just a warning. This one was a percentage based, so if I said that my input is only 70, then it calculates percentage-wise the output accordingly. So I think I don't need to do the rest. I think it becomes clear. And then let's do one more example of a slightly advanced feature. Get out of here. Yes. In this case, we'll be doing what we call linear calculation. This time it's not a temperature gauge, it's a pressure transmitter. And for the pressure transmitter, you have different outputs and inputs. And I've checked this linear calculation flag here. And if you look at this range, you see that your input range is up to 100 bar, while your output range is 500 milliamps. Looking at the sequence down here, you can see that I no longer can enter the output myself manually. It is calculated based on this ratio. So there's clearly a 1:5 ratio, and so the output is then calculated based on that. So for 10, it's times 5, the output is 50. And on this one, I put a percentage of the range of 10%. And then what that will look like when you're doing a results recording is as follows. So it calculates here your specification based on the 50. And if I had done an input based on output kind of thing, which would have been maybe a better example, then the input, if I entered an input, the output, the specification would obviously adapt based on my reading. So those are the the different types of calibrations we can support. We have another 15 minutes or so, so I'll briefly go over to some of the reports that we have as well. So we have a trace where we can see, for example, where a standard was used. So previously in my example, I used this standard. So let's say now we had a production run and we come back and we realize maybe one of our standards was out of spec. Here we can go back and see where, during which calibration and which inspection lot this standard was used. So in this case, it was only used once, so that wouldn't be such a big problem. But if you had a longer list, you could go and deal with that then. So this just allows you to go and look at where standards were used. Then we have one that allows me to see where an equipment itself is assigned. See if this returns anything. Yeah, so for that equipment number, it's assigned to this data sheet. So if you forgot which data sheet you have this equipment specified on, this is an easy way to find it. And then lastly, we have the audit functionality. So for, let's say, this data sheet, I can view who made what kind of changes and when, so that you can you have this for an audit if need be. So that summarizes, and that's all we have in terms of QMC for today. Let's go over to the Q&A session, and let me go look if we have any questions posted. Okay, so first question, how do datasheet functions relate to work order operations? Yes, I touched on this briefly. For each of the functions that you have defined in your datasheet, QMC generates an operation on the work order. So we can actually, if I go back to just our previous example, where we had this one, you'll see up here on the left, this is the operation that was generated. So if I had more than one function defined, we would have multiple operations. Okay, let me. So the next question here is, can we customize the inspection lot data to a regulatory report form? Yes, so I think you're referring to the calibration certificate most likely. Yes, we can make this look any way you want to, really. It's a smart form. So yes, perfect. That is the answer they were looking for. So yes, we can customize this smart form for you so that it conforms to regulations. And there's another question. How is the recording of lab standards different to the standard way of doing it in SAP? So as I mentioned earlier, in SAP, if you want to specify which lab standards to use, you have to do this on the task list already, on the operation, on the PRTs, on the operation on the task list. So when you are then out in the field, you cannot change the standard that you have to use now all of a sudden, because it has been hard-coded, even if you accidentally grabbed a different, although equivalent standard. Next question is there a recording of this webinar available for review? It will be available. Is that correct, Asha? While she finds her mic button. I do believe, yes, it will be. Okay, I don't see any more questions out there. Feel free to obviously contact us by email if there are any related questions, and we are always willing to do another demo for you as a customer individually. Thanks everyone for joining us today.